Well, this is John Black, Super Chemist. I don't even know what part this is. I think it's part 6. It's getting ridiculous. As you know, for the last part I did, obviously I failed on making my nitrocellulose. I did find out that because I used a t-shirt, 100% cotton, it said it is not 100% cotton, BS. I'm going to go down and get that brand again and do a video on that brand because they're a bunch of filthy liars. Is it mostly? Because, yes, it is mostly cellulose, but you'll see from the experiments I'm doing here that it is not 100% cotton, okay? The first two experiments, what I did was I started at the ratios, because the ratios that I did in the video, I just assumed, because the ratios are so outrageous, okay, on my original recipe. You know what I mean? It's like a ratio of, I'm just making up numbers, but, 1 mole cotton, and you need, 20 moles of, nitric acid, and, you need like a liter of nitric acid. You need like 4 or 5 liters of sulfuric acid. I mean, that's a lot of acid alone, but let alone distilling 1,000 milliliters of nitric acid. That's time consuming, man. So I assumed that because I was, when I got this recipe, this was like 30 years ago, you know what I mean? And I thought the guy was just telling me to put extra in as filler. It was all filler, you know what I mean? Only some of it was filler, though, apparently, I guess. And you really do need these outrageous ratios, you know what I mean? Like, for a mole of cotton, you need like 90 moles of sulfuric acid or something like that. I mean, 90 moles to 1, that's ridiculous, okay? That is ridiculous. So anyways, here's the original recipe that actually works. For every gram of cotton, you put in 21 grams of potassium nitrate. That'd be 36.6 milliliters, okay? Keep in mind, this is milliliters, this is grams. So if you have 2 grams of cotton, you times this by 2 and get 41, times this by 2 and get whatever that is, 70, whatever it is. So that does work, okay? But my t-shirt, remember, a whole mole was like 130 grams or something like that. I mean, I can't remember, 128 maybe or something, I don't know. But can you imagine 128 grams times 21 grams of this? And then 128 grams times 36.7, you know how many milliliters that is? That's a lot. So basically, I assumed all this was excess because, you're doing small amounts, it's filler, and you're just adding in so that you totally get nitration. There's no doubt about it. If you're doing 10 cotton balls, who cares if you throw a little bit extra in, you know what I'm saying? But that isn't the case. You actually need that ratio, that high ratio, okay? So I did some experiments. I started from the ratio that I used in the video where I failed. And that ratio was for every mole of cotton, I put 4.3 moles of nitronium ions. Meaning I had the same, these were 1-to-1 ratio, but for the cotton to the nitronium ions that this makes was a 4.3 to 1 ratio, okay, which is not enough. So I did that with cotton balls, right, with that ratio, and the cotton ball just dissolved, okay, it literally dissolved in the water. There was nothing there was nothing left. It just dissolved in the water. There was nothing to scoop out. So I raised up the ratio a little bit more, putting more potassium nitrate and more acid in there, and again it dissolved. There was nothing to scoop out. There was no solids, okay? Now here is where I jacked it up a little bit more, and you'll see that there's it more burns than flashes. You know what I mean? You don't really see a flash at all, okay? And here it is right now. Now here are these next two ratios of acid. They're exactly the same. Okay, I jacked up the ratio again, right, because I didn't even get a flash from that last one, right? So I jacked it up, but this time I thought that this was my original recipe, so I did the cotton and I did the t-shirt so that you can see the comparison between the two. And you'll see that the t-shirt is obviously 100 times less flashy than the cotton balls. Okay, so the cotton balls are 100% cellulose. I'm doing the same recipe. They should be the same exact flash, and they're not. So you can see that the t-shirt is not 100% cotton. They're a bunch of liars. They're filthy, stinking liars. This right here, 1 gram, 10 grams, 36.7 milliliters. This is the ratio for this coming up gun cotton, for the t-shirt and for the cotton balls. And as you can see, it doesn't work. So anyways, here it is. Check it out. Now you can see it did flash this time, right? And well, the cotton flashed. The t-shirt that was supposed to be cotton kind of burned. You know what I mean? There wasn't really no flash at all, was there? So anyways, here's my original recipe, this right here. All right. And I did it again. I did the cotton balls and I did this t-shirt. So they're nitrated the same exact way, exactly the same way, right? And you'll see, check them out. Here they are right here. Oh, jeez. Wow. There's nothing on there. Oh! Whoa! Now you can see when I did the cotton balls, it flashed big time, right? It left not even one little piece of soot, nothing. There was not even a crumb, right? But when it did the t-shirt left, it was a flash too, it was pretty good, but it left, I think it was a slower flash for one, you know, it lasted longer, which it's not supposed to. And the other thing is, as you can see, there's a black, you know, exactly the size of the shirt or the cotton that I put on there. You'll see like a shadow, you know, from the soot that was left. Now, if it was 100% cotton, we proved with the cotton ball that it disappears with that recipe. So, and I used the same exact recipe on the t-shirt. So it should disappear completely too, and it did not. But mostly it did. It was actually pretty good. But there was soot, so that proves that it's not 100% cotton. It's close, Don't get me wrong, it's close, but it is not. It's not 100. They're liars. They're committing fraud by putting on their package that it's 100% cotton when they know damn well it is not. So anyways, I'm going to get off here and do the math and show you the ratios, what it would be like if you use nitric acid and sulfuric acid instead of this. Keep in mind, when you make stuff in situ, you know, like this here, since there's such an abundance of sulfuric acid compared to the nitric acid, you know, this is like, what, a fifth of a mole, and this is like 80% of a mole, you know, so 20% and 80%, that's you have a lot more here. You have 4 times as much molar-wise than you do this. So you're definitely going to get 100% nitric acid, you know what I mean? But if you do this next method where you use nitric acid and sulfuric acid instead of making it in situ, you're going to distill it out. So you're going to lose a little bit, right? You're only going to get 93% or something like that. So anyways, I'll figure it out, and we'll see what it is when you use just acid, not this easy method. Anyways, that's it. I did prove that that shirt is not 100% cotton. Now, if you were going to use nitric acid instead of making it in situ, you'd have 1 gram of cotton. For every 1 gram of cotton, you'd use 8.7 milliliters of nitric acid and 25.7 milliliters of sulfuric acid. You need a little bit less because some of that is just, you know, 11 milliliters of it is just used to make the nitric acid in situ. Okay, so this would be equivalent to this up here, right? And the method in the video, even though the video is a failure, the method from part 1 all the way up to part 5, they're all viable. It's all good stuff, you know what I mean? The only thing is, and I think I even mentioned in one of the videos that I really didn't know the ratio of cotton to nitric acid. I just knew there was 3 hydroxyl groups. They needed nitrated. So if I had a mole of cotton, I'd need 3 moles of nitronium ions. You know what I mean? And I put in 4.3. It didn't work. But this ratio here does. This is the original recipe. Now you can see here, this is the last. I kept scaling it up from my failure, right? The amount of acid per cotton, right? And the last thing I did was this ratio right here, 1:10:36.7. And you can see the cotton didn't, all it did was burn when it was the t-shirt, right? When it was the cotton balls, it gave a flash and then it burned, left a lot of soot. The shirt, it barely did anything. I mean, it burned it, but it didn't flash at all or nothing, you know what I mean? So you could maybe scale this down a little bit more, somewhere in between this and this, right? We know this works for sure. That's my original recipe. Even on the t-shirt that wasn't 100% cotton, it gave a good flash, big flash, but it did leave a little bit of soot, you know what I mean? So, but that isn't the recipe's problem. That's the shirt, because we proved it with the cotton balls. The cotton balls, there's not even no soot whatsoever, nothing. Great flash, fast, you know what I mean? But you might be able to scale this down somewhere in between 20, you know what I mean? Somewhere in between this. Well, this is going to stay the same. But this, you might be able to scale it down a little bit more. You might even be able to scale this down a little bit more. I don't know. But I did learn some stuff about making it. You know, before this video, all I had was this recipe here, you know, and a bunch of mismatched information. So I did the experiments, I learned some stuff, and now I know what's up. And next year I'll try to go in between here and see what happens if I can lower this down, because this is crazy amount. For a gram of cotton, that's like 1 cotton ball, say, is about a gram. You're going to add 21 grams of this and 36 of that. I mean, what if you make 100 grams? That means... Anyway, so that's it, y'all. Have a great day, and always remember, science is great.